Write in component form. This is a vector, like from Minions or Despicable Me or whatever train wreck that was. A vector is basically an arrow that's defined by the direction that it's going and how long that arrow is. The length of the arrow is called magnitude. Okay. Component form looks like this. It looks like a point, and in a way it kind of is. This basically says, let's just pretend we don't care where this arrow started from, but it goes x units to the right and y units up. If x is left, then it's negative, and if y is negative, then it goes down. So if we have an arrow that goes like this, we can expect to have an xy of positive negative because it goes right and down. Now, the way we find this is r is my starting point for this vector. So we are going to call r, that's a p, so we're going to call r x sub 1, y sub 1. And we're going to call s, which is the arrow, x sub 2, y sub 2. So in order to make this look like this, we are going to use this formula right here. In this case, we're looking for RS in component form. This is not like a formula that you'll find like on the internet, although I'm sure many websites would have it. This is just how I decided to do it. Okay, the x value comes first, x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. In this case, x sub 2 is 8. Minus x sub 1 is negative 3, so we have a double negative. Deal with that in a moment. Y sub 2 is negative 1 minus y sub 1 is 9. Do a little bit of simplifying. Double negative makes that a positive. You have 11. Negative 1 minus 9 is 10. Negative 10. And that's my guy. And you can kind of see it here. This goes right 11 spaces, down 10 spaces. That's my vector in component form, the end. I am to write this vector in component form. Remember, component form looks like this. It looks like a point. And this point tells you how many units to the right my arrow is going and how many units up my arrow is going, and negative means the opposite direction. Now, this gives me something that looks like polar coordinates. It gives me a magnitude, which means a length of 52, and a direction of 174. So if I'm looking at this as if this is something written in polar coordinates, I would have that. Okay, I would have a vector that looks like that. So we should expect a pretty big x value and a not so big y value. So how do we do this? How do we find x and y? Well, we kind of remind ourselves about polar stuff, and we use the fact that x equals r cos theta. That's my theta. Nope, that's my theta. That's my r. And y is going to equal r sine theta. So x is going to equal 52 cos 174 degrees. Y is going to equal 52 sine 174 degrees. This is definitely a calculator exercise. I'm not going to pretend like I'm even going to do this in my head. When you type this all into a calculator, the x value that you get is negative 51.7151. And the y value that you get is 5.435. Again, these numbers kind of make sense. This line is 52, and it's pretty low. It's pretty close to the x-axis. So it's going to go 51-ish to the left and only about 5 up, and that's going to be how I get to the end of that vector. But there you have it. Draw a diagram and find the magnitude of this guy right here. Oh, right? I don't know why I have to find the magnitude. I already have the magnitude. That's my magnitude. Maybe I'm just supposed to draw the diagram. I don't know, but let's go above and beyond. This is me drawing a diagram. Okay, here's 0, here's 90 degrees, here's 180 degrees, 180 degrees. 230 degrees is 50 more than 180. 50 degrees more than 180. And we could say that the length here is 15. So that's my magnitude. Let's double check that, though, using some knowledge that we have based off of components. I know r squared, okay, is going to equal x squared plus y squared, which means r is going to equal the square root. X is the same as r cos theta, r cos theta, not rose theta. That would be a prickly mistake. Squared. Plus r sine theta squared. R is 15. Cosine 230 squared plus 15 sine 230, close it, squared, move that over. This ends up being 92.965. This ends up being 132.035 gross. Okay. Those two numbers coincidentally add up to 225, and the square root of 225 is 15. So, the magnitude is the distance of my radius. That's what the R stands for. So the fact that it gave it to us like that and asked me to find the magnitude, I'm not sure. Sometimes I wonder when I make these problems, I copy and paste them off of other things, and I wonder if I copy and pasted it wrong. But at the very least, we kind of did a nice little proof to find out that I was right. And we drew a diagram, which is part one of what we had to do. So, everybody wins. Unless you hate square roots, in which case you lose. Find the magnitude and the direction angle of this vertex in component form. All right, I need to find the magnitude and I need to find the direction angle. Let's draw ourselves a very basic diagram of what we're dealing with. Okay, I'm doing Q3, quadrant 3, because this is basically saying if I were to start at the origin, go left 8 and down 41, that's going to be what I have. So this right here is the magnitude. Okay, in order to get to the end here, I go left 8 and I go down 41. Now, what I tried to make there, and I did poorly, so I'm going to do it again. What I tried to make there was a triangle. That's much better. I need to find this missing side. Not only do I need to find this side, I need to find this angle here, and of course do a little bit extra with that, but let's focus on the magnitude first. Okay, if I were to take that right triangle and pull it off to the side and say that you're 8 and you're 41, I'll call you C and do Pythagorean theorem to find the length of that hypotenusy-looking thing. So I have 8 squared plus 41 squared is equal to C squared. Square root everything, and that gives me C equals 41.773. So that's my magnitude. My magnitude, R, is 41.773. Now what I have to do is I have to find that blue angle right there. If I were to look at this blue angle and compare 8 and 41 to it, 8 is adjacent to the blue angle and 41 is opposite. So we need TOA, which means the tangent of that blue angle is going to equal the opposite side, 41, over the adjacent side, 8. So let me actually give myself a little bit more space. You'll see why 41 over 8. To get that theta all by itself, we inverse tangent. So inverse tan, inverse tan. Theta is going to end up equaling 78.96 degrees. However, I'm not done. That angle is 78.96. I want all of this, which means I have to add 180 to it. And when I add 180 to it, the resulting angle is going to be 258.96 degrees. Ooh, close to 98.6 degrees, which is average body heat. Like and subscribe. Sketch a graph and find the magnitude and the direction angle of 5i minus 12j. Is that I the same as the imaginary number I? Nope, not at all. I basically means that this many units in the x-axis direction, and j means that many units in the j direction. So, or the y-axis direction. So, I don't have near enough space. So why don't I go by fives for these 5, 10, 15, 20. You'll be -5. You'll be -10. You'll be -15. If this is going 5 in the positive direction, I'm going to go over here. 12 in the negative direction has me ending up somewhere around here. So the picture that I get is going to, boy, that's awful, 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 awful. The picture that I'm going to get is going to end up looking something like that. Now, what does all this mean? What does all this mean? Well, first off, went right 5, went down 12, gives me a picture where I can imagine a triangle that goes right 5 down 12. I have to find the magnitude, so let's do that first. Let's call you C. Okay, so this is Pythagorean theorem. 12 squared plus 5 squared equals C squared. 144 plus 25 equals C squared. 169 equals C squared, square root it, and C equals 13. So the magnitude is going to be 13. What I don't have is the direction angle. Now what I'm going to do is I'm going to find that angle in blue right there. Now, if let's just say that I get 50, which I don't, but let's just say that I get 50. Does that mean my answer is 50? No, not at all. That means my answer is going to be 50 plus 90 plus 90 plus 90 plus 270 total, because my direction angle is going to have to be like 200 or 300 something, because it's going in that direction. So what I need to do now is I have theta. 12 and 5 compared to theta are my adjacent sides and my opposite sides. So I'm thinking SOHCAHTOA thoughts, which means that the tangent of my theta is going to equal the opposite, which is 5, over the adjacent, which is 12. Didn't leave myself enough space at all. So let's just inverse tangent both sides. I know that looks very sloppy, but I'm not going to rewrite it. Inverse tangent both sides, so that crosses out. Theta equals the inverse tangent of 5 over 12, which is 22.62. So this guy right here is 22.62. I have to add 270 degrees because 90, 90, 90. And when I add 270 degrees, that gives me a direction angle of 292.62 degrees. And that, ladies and gentlemen, is my magnitude and my direction angle. Cool. Write the component form of the resultant vector. What this is basically saying is U is going to look something like this. Let's multiply -3 to it, which means you flip it, do it again, and do it again. How long is this? Now 3 times because it's 3 and flip it because it's opposite. So the way that I answer this is I multiply -3 to the regular component form of the vector, and that gives me -60, +63. And if you're like, that's it? That's all we have to do? Yeah, that's it. Yeah, that's all you have to do. And that's kind of a picture of what we got. Pretty easy. Find the component form of the resultant vector. If I give you tx, they're points, yz, they're also points, and I need to multiply 4 to tx and add yz to that. Well, first off, we need to find the vector tx in component form. Okay, the quick way of doing this is you take 3, you subtract -3, so 3 minus -3 is 6. Okay, this gives us the fact that I'm going from -3 to +3, so that's 6 units total. 10 minus 8 is 2. YZ is going to be -4. I'm sorry, -8 minus -4. That would change things. -8 minus -4 is -8 plus 4, so -4. And -10 minus -7, which is -3. Okay, I have a video on turning points into component form. If you're like, he went way too fast for that, I understand. But, you know, I offer no apology. Now, what we're doing here by adding these two up is Tx is 6, 2, which means looks something like this. So if I take 4 of them, 1, 2, 3, 4, and then if I were to go from there, so this is 4tx, if I were to go from there and go in the direction of yz, which is -4, -3, go here, so this is yz. Again, my picture is not going to be perfect. What's the resultant vector if I just went from the very beginning to the very end? Okay, what's this going to be? Well, what you do is you take 4, you multiply tx to it in component form, which is 6, 2, and then you add yz to it. 4 times 6, 2 is going to be 24, 8, plus -4, -3, ends up being 20 and 5. So if I were to be like, tx is this way, but you need 4 of them, then go yz. And if someone's like, I'm just going to go from the very start to the very end, the very start from the very end is right 20 up 5. Dunzo. Find the magnitude and direction angle of the resultant vector. Resultant vector means you're going to take, I don't know, a vector or 2 or more and like add, subtract, multiply, do stuff to it to get an answer. Resultant vector. In this case, we're taking a and b, and we're multiplying -3 to a, and we're subtracting 7 times b. Let's find out what that is first. So -3a is going to look like this, and then we're going to do -7 times b, which is going to look like this. Okay, multiply. Whenever you have component form, just multiply. That becomes 9. That becomes 36. Same thing again, multiply positive. That becomes, I'll throw negatives in there, negative 28, negative 63. And then when you add these guys up together, you get negative 19, I think, and negative 27. All right. Let's get a nice little visual going. Okay, negative 19, negative 27 means in order to draw this picture out, you go left 19, you go down 27, and then you have something that looks like this. Now, fig number one is you went left 19, you went down 27, so I have myself a Pythagorean theorem-ish type problem, which that's how I'm going to do this first part. But I'm going to use more of this formula now. I'm going to move away from a squared plus b squared equals c squared and move more towards the radius version of it, which it's the same thing. In fact, it's not going to be by saying it's the same thing, I actually started writing out the same thing, which is the opposite of what I wanted to do. R equals the square root of x squared plus y squared. You've seen that. So in order to find the magnitude r is going to equal the square root of 19. Actually, we'll put negative 19 just to prove the point that this becomes positive. We're going to be consistent. And negative 27 squared. I'm going to do this mentally and not use a calculator and find out that this becomes 33.015. Big brain. Now, what I have to do is I have to find also the direction angle. Now, if this is a coordinate plane, I've got 90 up here, I've got another 90 here, and I care about that theta. I need to find theta and then add 180 degrees to it. So I do know that tangent theta equals the opposite over the adjacent. So 27 over 19. In order to get theta all by itself, we're going to inverse tan, which means you stay in the shadows. Get it? And that gives me a theta of 54.865. Did that in my head too. Now that's just this part here. In order to get the direction angle, I have to include the fact that it starts over on the right side of the x-axis and winds its way around counterclockwise. So 180 plus this is going to give me 234.865 degrees. So that's my direction angle. This is my magnitude. And that's the problem. Dunzo. Find the dot product of the given vectors. So I have u and v. So dot product looks like this. U times v is found by doing the x value in u times the x value in v plus the y value in u times the y value in v. So the x value in u is 3. The x value in v is 6. Plus the y value in u is 9. And the y value in v is 5. 18. 45. 63. It's my dot product, baby. Find the dot product of the given vectors. All right, we have a picture, which is unnecessary because when you find the dot product, what you do is you multiply the x values, so 8 times negative 7, add the product of the y values, so 4 times negative 9. This gives me negative 56. This gives me negative 36. This gives me negative 92. And that's that. State if the two vectors are parallel, orthogonal, which means perpendicular, or neither. So basically what I'm looking at, if I were to look at a picture of this, okay, if I were to look at a picture of this, whenever I'm given the form where I have i's and j's, this basically just means left 5 down 2, so I would have something that looks like this. This guy means left 10 up 25, so I would have something that's going to go way off the rails but looks like that. Okay. Now it looks, based off of the picture that I created, that it looks pretty orthogonal to me. Okay, but that's not good enough. Let's use a little bit of common sense here. Okay, vector u, is given to us by the fact that we go left 5 units, down j 2 units for j. I'm going to find the slope. I'm going to call it m sub u. Okay, the slope is the change in the y values over the change in the x values. Okay, if I'm going left 5, then my change in the x value is left 5. And if I'm going down 2, then my change in the y values is down 2, and that gives me a slope of 2 over 5. So the slope of this guy right here is 2 over 5, up 2 over 5, up 2 over 5, yada, yada, yada. Now, if I were to do the same thing with v, and I'm not going to write it out, there's v right there. If I were to say mv is the change in y values over the change in x values, the change in y values is positive 25. The change in x values is negative 10. That simplifies to negative 5 over 2. So when you look at the two slopes, 2 over 5 and negative 5 over 2, they're negative reciprocals of each other. Flip them, make one of them positive, make the other one negative. They're negative reciprocals, which tells me that these two lines are perpendicular, or in vector terms, orthogonal. Not to be confused with orthodontist, who fixes your teeth. Like and subscribe. Find the measure of the angle between these two vectors, 3, 6, 3, negative 8. The way to do this is you use dot product and use this formula right here. Cosine theta is going to equal the dot product of A and B, A being one of these guys, B being the other one. And then you find the magnitude of A and multiply that to the magnitude of B. Okay, so let's do everything one step at a time. The dot product of A and B means you multiply the x values, 9, add, multiply the y values, so 6 times negative 8 is negative 48. And so the dot product ends up being negative 39. The magnitude of A and B, we're going to use this formula right here, which is basically, something somebody stole, and I keep doing this, I always do this, but somebody stole the Pythagorean theorem. I should have used x and y, but, too late. But if I'm doing the magnitude of A, and I believe I called this one A, not that it matters, it's going to be positive 3 squared plus 6 squared. Type all that into a calculator and you get 6.708. To find B, which I'm calling that B, I'm going to use this formula again, square root of 3 squared plus negative 8 in parentheses squared. Type that into a calculator and get 8.544. Now that I know all this, I can plug it into that formula. So cos theta is going to equal negative 39 over 6.708 times 8.544. That terrible, terrible, terrible number ends up being negative 0.680472. How did you do that, sir? I did it in my head. No, I didn't. I have it written down. Let's inverse cosine. Let's inverse cosine. And my final guy is going to be 132.881 degrees. Fantastic. Find the projection of U onto V. I'm not even going to attempt drawing what projection means, but it kind of is like draw this guy and draw that guy and have it extend, and it's just terrible. So I'm not even going to attempt it. But we do have a formula for projection, and the formula for projection is this. Projection of U onto V is going to be the dot product of U and V over the magnitude of V, square that, and then multiply the whole thing by V. Okay, so first things first, let's find out what the dot product of U and V is. So 8 times negative 7 plus 2 times negative 3 ends up being negative 56, negative 62. So there's the top part. There's my dot product. Magnitude is going to be found by using this guy. Use this a lot. So I care about V, and I care about squaring it. So the magnitude of V squared is going to be the same as this guy squared, which is going to end up canceling each other out. We'll deal with that in a moment. But this is negative 7 squared plus negative 3 squared. So 49 plus 9 is 58. Square and square root cancel each other out. 58 it is. All right. So now what I have is I have a fraction, and I'm going to multiply it to this vector right here. I'm going to multiply it to that vector right there. So I have negative 62 over 58 multiplied to the vector V, which is negative 7, negative 3. Negative 62 over 58 actually simplifies to negative 31 over 29. How about that? Who'd have known? And just multiply that fraction to both of these numbers, and you end up with a terrible, terrible, terrible fraction. 217 over 29. And 93 over 29. All right. Write the vector in component form. 3 dimensions. Ooh. Well, if it was 2 of these, it was simple. We just kind of, it started at A, it ended at B, negative 2 minus 0, negative 3 minus negative 2. Well, now we're adding 7 minus negative 1, so this is not going to change in the slightest. Okay, so component form is going to be negative 2 minus 0, negative 3 minus negative 2, and 7 minus negative 1. Double negative makes a positive. Double negative makes a positive. Negative 2 minus 0 is negative 2. Negative 3 plus 2 is negative 1. 7 plus 1 is 8. And there is my 3D vector in component form. Awesome. Find the magnitude of each vector. Well, we're used to seeing the magnitude found by using this formula right here. Okay, x squared plus y squared. But we're going to add a z squared because this is 3 dimensions now. So this is going to end up being 2 squared plus 7 squared plus 5 squared, which ends up being the square root of 4 plus 49 plus 25, which ends up being the square root of 78, which ends up being 8.832. So if you were to imagine a 3D arrow pointing somewhere in space, this guy is 8.832 units long. In space! Find the component of the resultant vector. All right, well, we have 3D stuff going on here, and all I'm doing is doing u minus g. So 0, 9, negative 4, minus 9, 7, negative 7. 0 minus 9 is negative 9. 9 minus 7 is 2. Negative 4 minus negative 7, double negative is 3. And we're done. Find the magnitude of the resultant vector. All right, so the magnitude of the resultant vector is basically I have P, I have Q. We're going to take the opposite of P. We're going to take the opposite of Q rather. We're going to take the opposite of RS, and then we're going to combine those somehow and then find the distance from the beginning to the end. Gross. Well, this is what we need to do first. What we need to do first is we need to take PQ and put that in component form. Okay? PQ in component form is going to be 1 minus negative 7, which is 8, negative 8 minus 7, which is negative 15, and negative 9 minus negative 7, which is negative 2. Lots of double negatives going on in there. RS is going to be negative 3 minus negative 7, so a double negative makes that a 4. 0 minus negative 3, double negative makes that a 3, and 0 minus 5 makes that regular negative 5. So that's PQ and that's RS. They want me to take the opposite of PQ, so the opposite of PQ, and then subtract away RS, so the opposite of RS. So let me write that all out. Negative 8, 15, 2 plus negative 4, negative 3, 5 is going to give me in component form negative 12, because negative 8 plus negative 4 is negative 12. 15 minus 3 is regular 12. 2 and 5 makes 7. Now, in order to find the magnitude of that, we use this formula right here for 3D vectors, x squared plus y squared plus z squared. And so I'm going to use, I'll just say the magnitude, r is going to equal the square root of negative 12 squared plus 12 squared plus 7 squared. Let's type that away into a calculator, and you end up with 18.358. Find the cross product of the given vectors. Well, ladies and gentlemen, I have news for you. The cross product of a vector is not fun. Not fun at all. Let's write out the formula and then go from there. We have, it's in component form, by the way, a sub y, and by the way, that's an a, so that would be the sub y, a sub y, b sub z minus a sub z b sub y. Okay, that would be your first in the component form. Then you have a sub z b sub x minus a sub x b sub z. And then part 3 is a sub x b sub y minus a sub y b sub x. Close. Okay, so there's my a, x, y, z. There's my b, x, y, z. Let's have some fun, shall we? A times b in vector form is going to be 5 times 2 AYBZ, AYBZ minus AZBY, which is negative 3 times 9. Okay, AZBY, so you should get the idea now. AZBX is negative 3 times 2 minus AXBZ is negative 9 times 2. And then we've got AXBY, which is negative 9 times 9 minus 5 times 2. I typed this into a calculator ahead of time. These numbers multiplied out to 90 or 73, 37. Ugh. These numbers multiplied and subtracted out to 12. And these numbers multiplied and subtracted out to negative, not 19, but 91. The year I was born. It's not true. All right. Find the cross product of the given vectors. All right, what I need to do is I need to find what these guys are in component form. So AB in component form is going to be negative 5 minus negative 6, which is positive 1, double negatives there, negative 5 minus negative 2, which is negative 3, and negative 3 minus 6, which is negative 9. CD, compact disk, is going to be negative 5 minus 8, which is negative 13, negative 4 minus 7, which is negative 11, and negative 1 minus negative 6, double negative, makes that 5. Now, the formula for this guy is an abomination, okay? So I'm going to call you A, I'm going to call you B, and I'm going to label these X, Y, Z, and X, Y, Z. Now, if you know anything about matrices, which I'm going to have videos on matrices, this has a very matricey feel to it. And you'll see what I mean as we start putting things together, but I'm not going to do that quite yet. I don't want to make it all matrixy stuff yet because I didn't get to the matrix section in pre-calculus, so I don't know, maybe I can connect the dots when I get there, but I ain't there yet. Here's the formula. You ready? The formula is A sub Y, so that would be U, times B Z minus A sub Z B Y. So like A sub Z, B, Y, what's that? A sub Z would be negative 9, B, Y would be negative 11. Okay, that's the first part. Then I have AZ, BX minus AX, BZ. Then I have AX, BY minus AY, BX. And now it's a matter of plugging things in. A sub y is negative 3, b sub z is 5, minus a sub z, which is negative 9, b sub y, which is negative 11. Okay, so you get the idea. We now have negative 9. B sub x is negative 13, minus a sub x, which is just 1, b sub z, which is 5. And then we have a sub x, which is 1, b sub y, which is negative 11, minus a sub y, which is negative 3, and b sub x, which is negative 13. Multiply and subtract. These guys end up being negative 114. Multiply and subtract. These guys end up being 112. Multiply and subtract. These guys end up being negative 50 cent. Candy Shop. Remember him? Shot like 5 times or something. Rest in peace. He's not dead, but, someday. Like and subscribe.